Hi friends, welcome back to ElectrAspirant, an assistance to electrical students for objective type exam preparation. It is an initiative of Department of Electrical and Electronics Engineering, Christ College of Engineering, Irnyalakuda. In this session, we are going to deal with question 76 to 100 of Assistant Electrical Inspector, Kerala Electrical Inspectorate, KPSC 2014. Let's move on to the questions. As question number 76 is already cancelled for PSC, let's start with question number 77. Rotor rheostatic method of speed control is used for. The answer for this question is option A, slip ring induction motor. For squirrel cage induction motors, the end rings are used for shorting the rotor bars. So, no external circuit can be added in the case of a squirrel cage induction motor. But in case of slip ring induction motor, there are slip rings so that external rheostat can be added to the circuit. So, the rotor rheostatic method is used for slip ring induction motor. For DC series motor and DC shunt motor, we can use the flux control for speed control method as a speed control method. And in the case of squirrel cage induction motor, V by F method can be employed for speed control. Let's move on to the next question, question number 78. What is meant by plugging in the case of a three-phase induction motor? So, plugging is a method of sudden braking in the case of an induction motor, and it is done by interchanging the two supply phases for quick stopping. So, answer for question number 78 is option B. The locking of rotor is actually known as cogging, and it is because of the magnetic locking between the rotor slots and the stator slots. Next, option C is actually starting of the motor with direct online. It is known as DOL starting for an induction motor. So, the answer for question number 78 is option B. Let's move on to the next question, question number 79. What is the condition for obtaining the maximum torque condition under running condition for a three-phase induction motor if R2 is the rotor resistance, X2 is the rotor reactance and S is the slip of the motor? For obtaining the maximum torque condition, we have to equate dTd by ds equal to 0, or we have to take the derivative of torque developed with respect to the slip equated to 0 to get the maximum torque condition. And by solving this one, you will be obtaining the equation as R2 is equal to Sx2. So, the answer for question number 79 is option C, R2 is equal to S into X2. Let's move on to the next question, question number 80. Torque developed by a single phase induction motor at starting is. So, in the case of single phase induction motor, at the starting it refuses to start the motor because of a pulsating torque is only obtained in the case of a single phase induction motor. Whereas in the case of a three-phase induction motor, a rotating magnetic field is obtained by which the motor will be starting automatically. So, in the case of a single-phase induction motor, at starting condition, the torque will be equal to 0. And for improving this only, we are using different type of starters like capacitor starter, split-phase motors, etc. Okay, so let's move on to the next question, question number 81. Reluctance motor is preferably for. So, reluctance motor is basically a single phase synchronous motor. As we know that synchronous motor is actually a constant speed motor. So, reluctance motor is mainly used for precise control methods or devices. And answer for question number 81 is answer B, timing and control devices. Next options are electric traction, AC series motor is being used. And for refrigerators, capacitor start is being used, capacitor start induction motors are being used. Then for lifts and hoists, three-phase induction motors are being employed. Okay, let's move on to the next question, question number 82. Phase displacement between the running and the starting winding of a capacitor start motor is nearly. So, let's draw the phasor diagram of this one. Let this be the voltage phasor, and the main winding will be lagging behind the voltage. Why? Because it is having some inductance. So, this is the main winding current. Now, what about the starting winding current? It will be having a capacitance in the starting winding. So, actually it should lead by an angle 90 degree. But as it is having some inductance also, it will be having a phase like this. So, the starting winding will be like this. The angle between main winding and starting winding is almost equal to 90 degree. So, the answer for question number 82 is option A, 90 degree. Let's move on to the next question, question number 83. Which of the following does not change in the case of a transformer? So, we know that the transformer is actually a constant power frequency device. So, the frequency remains constant for the case of a transformer. Whereas, the voltage and the current will be changing both for the case of a step up and a step down transformer. Let's move on to the next question, question number 84. The highest transmission voltage in India is. The highest AC transmission voltage in India is 765 kilovolt. It is from Raichur to Sholapur, and the highest DC voltage transmission, it is plus minus 800 kilovolt, and this is from Agra to Assam, and it is about 1728 kilometers long. So highest DC voltage is 800 kilovolt and highest AC transmission voltage is 765 kilovolt. Okay, let's move on to the next question. Question number 85. Which of the following transformers has its secondary always kept closed? So answer for question number 85 is option D, current transformer. So the current transformer's secondary side should be always in a closed condition. If it is in the open condition, a high voltage is appearing across the current transformer, across the secondary of the transformer. Why? Because it is actually, or basically, it is a step-up transformer. Step-up means the voltage is being stepped up. So high voltage appears across the secondary of the transformer, which will cause the core to be saturated, as well as it causes very high danger for the person who is operating the transformer. Okay, so let's move on to the next question. Question number 86. It is a problem. 40 kVA single phase transformer has a iron loss of 400 watt and full load copper loss of 600 watt. What is the maximum efficiency occurs at a load of? So the answer for question 86 is, we can easily solve it by a simple equation. X square into full load copper loss, I am just representing it as WCU, is equal to the core loss, let it be Wi, that is the iron loss. Okay, X represents the percentage of load or the fraction of load at which the maximum efficiency is occurring. The iron loss, it won't change. Why? Because it is constant for any type of load. But the copper loss changes with X square. Okay, now just substitute this one to find the value of X, or how much fraction of the load is being there during the maximum efficiency time. It is obtained by the root of Wi divided by WCU, which is equal to root of 600 divided by, root of 400 divided by 600, from which you will be obtaining X value. Now, the load at which this maximum efficiency occurs can be found as X into 40 kVA. So, your answer for this question is 32.66 kVA. The option is C. And let's move on to the next question. Question number 87. Which winding of the transformer has the large cross-sectional area? We know that the resistance and area is inversely proportional to each other. Large cross-sectional area means the resistance is low. Resistance low means it can carry more current. For the case of a transformer, power is equal to voltage into current. Power should be maintained as a constant. So current should be larger, or current carrying can be larger, which means the voltage should be low. Or we can say this condition is for a low voltage winding. Answer for question number 87 is option D. Let's move on to the next question. Question number 88. During short circuit test, the iron losses are negligible because. So we can say that the iron losses are directly related with the voltage applied, and the copper losses are directly related to the current being carried by the winding. Square of the current being carried by the winding. So in this case, we can say the option is B. Voltage applied on the primary side is low. That is why we are neglecting the iron losses in the case of a short circuit test, and we are only obtaining the copper losses in that case. Let's move on to the next question. Question number 89. If the input to the prime mover of an alternator is constant, but the excitation is changed, then what happens? Okay, so we have to study this thing. Input is actually related to the active power in the case of a alternator, whereas the excitation, it is related to the reactive power. Okay, so if the input is changing, the active power will be changing, and if the excitation is changing, the reactive power will be changing. So the answer for question number 89 is A. Reactive power output will be changed if the excitation is changing. Okay, let's move on to the next question. Question number 90. For a sine wave oscillator, total phase shift around the loop and the magnitude of the loop gain must be. For a sine wave oscillator, the total phase shift. So basically we can say it is consisting of an amplifier and a feedback, as it is a loop. Okay, the amplifier creates a 180 degree phase shift and the feedback creates a 180 degree phase shift. So totally 180 plus 180, 360 degree phase shift is being created, or it is we can say it is same as 0 degree. Okay, so 0 degree phase shift is being done and the loop gain is unity. So the answer for question number 90 is A. Let's move on to the next question. Question number 91. The first column of Ruth table consists of the following numbers. Okay, the system is. So the Ruth table, in the Ruth table, if the first column consists of numbers having the same sign, then we can say that the system is a stable one. Now what about if there is any change in the sign? If there is any change in the sign, the number of sign changes are to be taken. If the number of sign changes will be equal to the number of roots that are present on the right hand side of the S plane. So that is regarding the Ruth table. Let's move on to the next question, question number 92. Effect of phase lag network is. So there are mainly three effects for the phase lag network. One is the phase margin is being increased. Secondly, the bandwidth will be reduced, and then the gain crossover frequency. The gain crossover frequency will be also increasing in the case of a lag network. Now let's move on to the next. So answer for question number 92 is option A. Let's move on to the next question, question number 93. If the bandwidth of the control system is increased, then the result will be, when the bandwidth is increasing, the response becomes slower. So that is the answer, option A. 93 option, and answer is option A. Let's move on to the next question, 94. But this question remains cancelled for PSC. So let's move on to the next question, question 95. In force current analogy, the electrical capacitance is analogous to. Answer is option B, mass. There are mainly two types of analogies, force current analogy and force voltage analogy. In force current analogy, the capacitance is analogous to mass. 1 by L is analogous to the spring constant K, and the current is analogous to the force. Okay, that is already mentioned. So that is regarding the force current analogy. Let's move on to the next question, question number 96. Which of the following is not in the frequency domain? So from the options itself, it is clear that root locus is a time domain analysis. Bode plot, Nyquist, everything is a frequency domain analysis. So answer for question number 96 is answer B. Let's move on to the next question, 97. If the characteristic equation of a system is s square plus 8s plus 25 equal to 0, what is the value of omega n? So the characteristic equation can be found from this equation. Omega n square is equal to omega n square divided by s square plus 2 theta omega n s plus omega n square. From this itself, it is clear that omega n square is equal to 25. From that, we can find out omega n is equal to 5. So answer for question number 97 is actually D. Now, if the question is asking about a damping ratio theta is damping ratio, we can also find that from this equation. 8 corresponds to 8 is equal to 2 into theta into omega n in this case. So from that, you can also calculate theta value. Let's move on to the question number 98. Phase shift of g of s is equal to 1 by s square is given by. So how can we find the answer for this one? Phase shift is actually given by angle of the numerator minus angle of the denominator. So in this case, angle of the numerator can be found as tan inverse of imaginary part by real part. Tan inverse of, in this case, tan inverse of, there is no imaginary part, so 0 divided by 1, which means 0, tan inverse of 0, the answer is 0 itself. Okay, now what about the denominator, theta in the denominator? So in the denominator, you can see 1 by s square, which means 1 by j omega into 1 by j omega. Okay, so j omega, what is the angle for this j omega? Theta is equal to tan inverse of imaginary part is 1 divided by the real part is 0. So tan inverse of infinity, which is equal to 90 degree. So 1 by j omega creates an angle of 90 degree. The other j omega also creates a 90 degree. So total we can say 90 plus 90, and the answer is 180 degree. So the answer becomes 0 minus 180, which is equal to minus 180 degree. And the answer for question number 98 is option A. Let's move on to the next question, question number 99. The open loop transfer function of a unity feedback system is given by g of s is equal to this much. What is the static position error coefficient Kp? So the equation for Kp is equal to limit s tends to 0, g of s into h of s. In this case, h of s is equal to 1. Why? Because it is a unity feedback system, and the only thing is remaining is g of s. So for g of s, we can substitute s is equal to 0, and the answer becomes 50 divided by 1 into 10, and the answer becomes equal to 5. Answer for question number 99 is A. Last question is 100. Schmidt trigger is an example of. Schmidt trigger is an example of bistable multi-vibrator, and it is mainly used for converting, or it's converting noisy input signal into a perfect square pulse. Okay, and its output remains in either in the any of the stable state indefinitely. That means if there is a need for change in the output signal, then surely there should be change in the input signal. I'll be showing you a simple example for this one. Let this be an input signal. Okay, and there are two threshold values, VTH minus and VTH plus. Then the Schmidt trigger output will be like this. If the input noisy signal is crossing the VTH plus value, then this Schmidt trigger will be triggering. Okay, and when the input signal is going below the VTH minus value, then again it will be triggering. Till there it will be in a indefinitely it is being there in the stable state. So it is mainly used for converting a noisy sine wave or triangular wave into a perfect square pulse. So that's all about the questions from 76 to 100. Hope you all understood about these questions. Stay tuned for the next videos. Thank you for listening. Do like and share this video, and also don't forget to subscribe our channel. Thank you everyone.